Now we have arrived to example 4. Integrate x squared minus 2x minus 1 over x minus 1 squared, x squared plus 1 dx. So this is the case of repeated linear, case B. This is the case of irreducible quadratic, so case C. So let's open up everything. Let's build up our repeated linear. The first part should be x minus 1. The second part should be x minus 1 squared. And for your numerator, this is just a constant. So A and this is B. And finally, this is irreducible quadratic. So this should be Cx plus D. So let's open up everything. For the first one, you need another x minus 1 and x squared plus 1. So let's multiply them. For the second one, you already have x minus 1 squared. So you need another x squared plus 1. So multiply that in both numerator and denominator. And finally, for this one, you already have x squared plus 1. You need another x minus 1 squared. So multiply both of them. Don't forget to write the bracket. Okay, so now you have the same denominator. So let's multiply both sides with x minus 1 squared, x squared plus 1, so that we can cancel out denominator. So let's rewrite back your numerator. So let's do something new here in order to find a, b, c, d. Let's mix up elimination method and also comparing coefficient method. Okay, so if you ask me my preference, I prefer to do elimination method. It is less risky, okay, but I will still show you another way, which is comparing coefficient. Okay, so first one, we have the factor x minus 1, so we can do elimination method easily here. So we can choose let x equal to 1. So when you let x equal to 1, your left hand side is minus 2, and when x is equal to 1, this is cancelled. This is cancelled and you are left only with this one. So 1 squared plus 1, this is 2b. So let's rearrange your b is equal to negative 1. So let's fill in this one, b is negative 1, and let's open up everything. So now if you want to further use elimination method, you can choose any value for your x, okay, because you cannot find any value that straight away eliminate. However, I will show you another way, which is comparing coefficient. How to do that? You need to expand everything, okay? Multiply this and expand this first. And then expand this further, a, multiply inside. And for this one, multiply inside this 2 factor here. So after you open up, this is it, the whole equation. So now let's compare the coefficient for the variable. The highest variable is x cubed. So from your left hand side, you have 0x cubed. So this is 0 for your left hand side. For your right hand side, this is it, the one in green. So you have a plus c. This is coefficient for x cubed. Now let's focus coefficient for x squared. This is it, the yellow color. So your left hand side is equal to 1. So it is minus a minus 1 minus 2 plus d. So this is it, write it back. Next one is coefficient for x, okay, so I have underlined with the green one here. So this is negative 2 for your left hand side. For your right hand side, this is it, a plus c minus 2d. And finally, for your constant, the one in pink here, your left hand side is minus 1, your right hand side is minus a minus 1 plus d. So write it back. So now we have finished writing 4 equations here. So let's do simultaneous equation. I will take this equation here, 0 equal to a plus c as equation 1, and this equation here, minus 2 equal to a plus c minus d as equation number 2. Now let's do 1 minus 2. So 0 minus minus 2 is 2. A minus a is 0, c minus c is 0, 0 minus minus 2d is 2d. Therefore, let's rearrange your d is equal to 1. Now, let's proceed. Substitute in equation number 3. Let's rewrite equation number 3 and substitute your d is equal to 1. Therefore, just rearrange this, your a will be equal to 1. And finally, you can substitute a is equal to 1 in equation number 1. So from here, c is equal to negative a. So since a is 1, therefore your c is equal to negative 1. So we have finished doing simultaneous equation. So let us rewrite back our answer. A is 1, B is negative 1, C is negative 1, D is equal to 1. So let's rewrite the question with the variable here. Let's fill in our A is 1, our B is negative 1, our C is negative 1, our D is equal to 1. So now let's split each and every equation here. So for the first one is integrate 1 over x minus 1 dx. For the second one, minus integrate 1 over x minus 1 squared dx. For the third one, this is the third one. Okay, so this is just minus integrate x over x squared plus 1 dx. And for the fourth one, this is it. Okay, this function here. So this is plus integrate 1 over x squared plus 1 dx. So let's solve this one by one. I have named it number 1, number 2, number 3, number 4. Let's solve it separately and rewrite the answer here. For number 1, integrate 1 over x minus 1 dx. This is just ln modulus x minus 1. This is very simple. Now let's see the second one, integrate 1 over x minus 1 squared dx. So let's use u substitution. Let u as equal to x minus 1. du over dx is 1, therefore du is equal to dx. So let's solve this. Integrate 1 over u squared du. So this is just integrate u to the power of negative 2. Bring the power up. So this is easy to integrate. At 1 to the power, divide by new power. So u to the power of negative 1 over negative 1. So this is just negative 1 over u. And let's back substitute our u. Therefore, the answer is negative 1 over x minus 1. So settle with that. Let's proceed to number 3. Integrate x over x squared plus 1 dx. So again, we need to use u substitution. Let u as x squared plus 1. du over dx is 2x. Therefore, dx is just du over 2x. Let's substitute here. So integrate x over u. So substitute du over 2x. So this is common term. Cancel out. 1 over 2 is a constant. Take it out. So 1 over 2 integrate 1 over u du. So this is very simple to integrate. This is just ln modulus u. So let's back substitute our u, which is x squared plus 1. And finally, for number 4, this is integrate 1 over x squared plus 1 dx. So you can just look at your formula list. This is equal to inverse tangent x. Therefore, let's substitute all of the answer here. Number 1, this is answer for number 2. So be careful, the answer for number 2 is negative. So negative, negative is positive. So this is answer for number 3. Fill this in. And for number 4, your answer is inverse tangent x. And don't forget to write plus c. Therefore, this is your final answer for example 4.